Hi guys, this is Kumar. Today we are going to learn about the structure of atom and the history of atomic theory. How does the atom looks like? If you look at this model, the atom may look familiar to you. This is a Bohr's model, and in this model the nucleus is orbited by the electrons which are in different energy levels. So these circles, you can see there are many circles around the middle, which is the nucleus. So these circles are the different energy levels. So we'll be doing this model in detail. But the atomic model has changed throughout the centuries. So we have been talking about the atoms like years and years before. But at that point of time, we are talking about 400 BC, and it looked like a billiard ball. So there were different scientists who gave different theories about the structure of atom. Let's look at these theories. So the first documented proof about the talking of atoms was in 400 BC, and it was a Greek philosopher, Democritus, who began the search for the description of matter more than 2004 years ago. So at that point of time, he asked one question, that is there matter which can be divided into smaller and smaller pieces forever, or there can be a limit where you can stop at that point and it's not going to divide any further. So Democritus thought that matter could not be divided into smaller and smaller pieces forever, and it comes to an end which is eventually the smallest possible piece that will be obtained, and this piece is going to be indivisible. And that piece which was indivisible, he called that piece as atomos, which is a Greek word meaning not to be cut further. So according to Democritus, the atoms were really small, hard particles, that they were all around in the material or the matter with the different shapes and sizes. And atoms were infinite in number, always moving and capable of joining together. But this theory was ignored and forgotten for more than 2000 years. After that, there were two philosophers, Aristotle and Plato, which said like everything was made up of four things, that is fire, air, water, and earth. So their ideas held sway because of their eminence as a philosopher, and it was not based upon the scientific evidences. So another scientist, John Dalton, which was in early 1800s, he was an English chemist. He experimented eventually, which led to acceptance of the ideas of atoms. So what he did, he deducted that all the elements are composed of atoms, and atoms are indivisible, as it was told by the scientist in the 400 BC. And atoms of the same elements are exactly alike. So if you name few elements like carbon, nitrogen, oxygen, if they are the atoms in the same element, they are going to be all the same. And atoms of the different elements are different. So the atoms of carbon is going to be different from nitrogen, and the atoms of chlorine is going to be different from fluorine. So compounds are formed by joining of atoms of two or more elements. So if you're talking about joining of atoms to make a compound, let's take an example of water, which is H2O. So hydrogen and oxygen are the two different elements which are having different kinds of atoms. So hydrogen is having typically a particular one type of an atom of hydrogen atoms, and oxygen is having oxygen atoms. So when they join together, they make compounds. So it's basically formed by joining of the atoms. So that was the Dalton's theory. And this theory became one of the foundation of the modern chemistry. So in 1897, there was an English scientist, J.J. Thompson, which provided the first hint that an atom is made up of even smaller particles. So what he proposed was plum pudding model. So why he compared with the plum pudding model was, he said that atoms were made up from positively charged substances, and in that positively charged substances there were some negatively charged electrons which were scattered about like raisins in pudding. So that's why his model was called as plum pudding model. So J.J. Thompson studied that he passed an electric current through a gas, and as the current passed through the gas, it gave the rays of negatively charged particles. So he concluded that the gas was not having any charge, then why there was some rays of negatively charged particles at the other end. So he concluded that the atoms are made up of negatively charged particles which are scattered in the positively charged atoms. Rutherford's gold foil experiment. In 1908, there was an English physicist, Ernest Rutherford, who was working on an experiment, and he was not even working to unravel the mysteries of atomic structure, but he got some results which made him think that what is the structure of an atom. So Rutherford's experiment involved firing a stream of tiny positively charged particles at a thin sheet of gold foil. So his experiment looked like this. He fired a ray of small beam, which was scattered beam, which was deflected from the gold foil, and so he came to a conclusion that most of the positively charged bullets passed through the gold atoms in the sheet of the gold foil without charging the cores. But some of the positively charged bullets did bounce away from the gold sheet because there was something solid in the middle which repelled the positively charged particles, and that he called that as a nucleus.